In this video, we are going to show creating a machine system such as a PLC MAP 201 using data acquisition style. Normally, to program a PLC, a graph set is needed to be designed first. Then, a ladder diagram is created based on the graph set. After that, the program from the ladder diagram is then transferred to the PLC. This system is also possible to be designed by using LabVIEW software by National Instrument and the Compact DAQ. The idea is that we need to recreate the ladder diagram in the LabVIEW. The system works by following the state, or in this case, keep function in the ladder diagram. A keep function is not available in the LabVIEW, so we can create it by using logic gates or the NOR gate. The combination of these gates produce a flip-flop. Flip-flop works just the same as the keep function. It has set, reset, and output. To set the flip-flop, the output from the previous flip-flop and the sensor, or in this case a button as placeholder for now, need to be true. To reset the flip-flop, the output from the next flip-flop or the stop button needs to be true. The first flip-flop needs to be triggered first by using a true constant after the program run to allow the next flip-flop to be triggered. This is also known as first cycle in the ladder diagram. The method is also the same as the graph set.
Here it is for the manual mode. And here for the auto mode. The difference is, for the manual mode, the start button is needed to be pressed to trigger the flip-flop or step, while for the auto mode, the start button only triggers the second flip-flop. The stop button resets all the flip-flop except for itself. The manual or auto switch is connected to a case structure. For manual mode, the machine runs by pressing the start button first. If sensor A0 is true, then cylinder A plus moves forward. Then sensor A1 is true, press the start button, cylinder C plus will extend. Then sensor C0 is true, press the start button, cylinder A plus and C plus will retract. Then sensor A0 is true, press the start button, cylinder B plus will extend. Then sensor B0 is true, press the start button and cylinder D plus extends and cylinder B plus retract. Then sensor B0 is false, press the start button, then cylinder D plus will retract. Same goes for the auto mode, except the start button is pressed only once.
Okay, finally, all of the inputs and outputs, which is the buttons and sensor, are replaced with DAQ assistant. For the inputs, acquire signal digital input is selected and generate signals digital output is selected for the outputs. The NI compact DAQ selected is 9178 and the module for the input is NI 9401 and for the output is 9472. 10 volts IR sensor for the input A0, A1, C0 and D0 are connected to the port 0, 2, 4 and 6 of the 9401 module. The output will be displayed at the LED section of the 9472 module. The output is also possible to be connected to a cylinder through any digital output module that is compatible with the compact DAQ. The acquired signal is then converted from dynamic data and the output signal is then converted to dynamic data to generate signal. That's all from us. Thank you.